Here is the lie you've been sold by every AI influencer with a Stripe account. More agents equals more leverage. You see the demos, you see 4 terminal windows spinning at once, and you think you found the ultimate hack to 10x your output. You haven't. You've just found a way to make your mistakes bigger, faster, and more expensive. Most people spinning up parallel Claude Code agents are doing this. Agent 1, build the front end. Agent 2, build the back end. Agent 3, handle the API. They hit run, they feel like a god for 10 minutes, and then the reality check hits. You end up with 3 separate systems that don't talk to each other, schemas that contradict each other, and logic that's been written 3 times, all differently. Then you go on Reddit and say, AI isn't ready for real projects. No, your system design isn't ready. Parallel agents aren't about speed, they are about reducing cognitive load per agent. If you don't understand that, you aren't an architect. You're just a prompt jockey burning VC money. Let me show you how to actually fix it. Let's look at this failure in slow motion. This is an information flow problem, not an LLM problem. In a naive parallel setup, your agents are running in silos. They don't have a water cooler. The front-end agent needs an API contract to render a single button. The back-end agent is currently inventing that contract, but because they're running in parallel, the front-end agent is just guessing. It assumes a camel case field. The back-end agent, meanwhile, decides snake case looks better today. By the time they finish, you have distributed confusion. What you really have are multiple blind workers operating on partial truths, and in software, a partial truth is just a well-formatted bug. The fix isn't better prompt. You don't need to be nicer to the model, you need to resolve all uncertainty before the first agent starts. If an agent has to decide on a schema mid-run, your architecture has already failed. Let's talk about the math nobody mentions because it isn't cool for the marketing department. When you run 4 agents in parallel, they aren't sharing a context window. There is no shared KV cache across those instances. Each agent rereads your entire codebase. Each agent re-reasons through the same logic. You are paying for 4x the input tokens for maybe 1.2x the actual speed. If your system isn't orchestrated, you're paying a 400% premium to get 0% working code. I'm not saying don't use parallel agents. I'm saying, know the price of the trade. If you can't justify the token burn with a perfect architecture, you're just lighting money on fire to feel busy. Real leverage comes from precision, not volume. Here is the 5-stage pattern that actually works in production. If you skip 1, the system collapses. Stage 1, plan. You don't write a to-do list, you build a directed acyclic graph, DAG. You identify exactly what must be finished before the next thing starts. This feels slow. It is the only thing that makes you fast. Stage 2. Lock. This is the most important step. Before a single executor agent runs, you freeze the interfaces. API contracts, data models, shared types, these are now law. If an agent tries to change a field name mid-run, the system kills it. Stage 3. Parallelize. Now, and only now, you run. But the boundaries are hard. Agent A implements the API. Agent B consumes it. They are forbidden from touching each other's files. No overlap, no guessing. Stage 4. Verify. A dedicated auditor node, which we'll dive into later, checks the output against the locked schema. It doesn't fix code, it issues a binary pass or fail. Stage 5. Merge. Only validated code touches the main branch. I'm going to give you the exact system prompts I use. Notice how boring they are, that's the point. Boring constraints produce reliable code. Prompt 1, the orchestrator. Its only job is to decompose the task into a DAG. It is forbidden from writing implementation code. If it writes a single function, it has failed. Prompt 2, the schema agent. This is your source of truth. It defines JSON schemas. No business logic, just the contract. Prompt 3. The executor. This agent is a prisoner of the schema. If the schema is unclear, stop and report. We don't want creative agents, we want predictable ones. Prompt 4, the auditor, a strict judge. Reject anything that doesn't match the schema. Prompt 5, the controller, the traffic cop. It enforces the sequence. No executor runs until the schema is locked. Parallel agents don't make you faster. They expose your architecture. If your system is clean, if your boundaries are hard and your interfaces are locked, parallel agents feel like magic. If your system is messy, they feel like sabotage. The skill you need in 2026 isn't prompting, it's systems thinking, dependency graphs, failure isolation, and interface design. If you can't design a clean API contract, start with one agent, master the one, then scale to the many. Plan, lock, parallelize, verify, merge. In the next video, I'm going to show you how to map this entire workflow into a LangGraph implementation so you can automate the orchestration. Subscribe so you don't miss the technical autopsy. What's your current bottleneck in your multi-agent flow? I'm reading the comments. See you there.